What are we voting for 18?
Yes.
Yes? We're voting for 18? Shh, okay, we're voting for 18. 18, here we go. So 18, quiet. Shh, quiet, here we go. It says find an expression. So we're building a function. What type of function are we building? Solnit, what? A piecewise function. Why is it a piecewise function? You can use the word. It's two functions. It's modeled by a linear function and what's that other one called? It's a semicircle. It's a curve. You could say curve, but it's a semicircle. First thing you could do to help you along would be to draw a picture of it. I think that would be a good way to start. So it gives you 2 points. Negative 2, 2. Let's make it right there. And negative 1, 0. So the first line is right here. And then it's an arc with radius 1. Now, I'd imagine most of you were able to get the equation of the line. Were you able to get the equation of the line? Yeah. And then you got stuck on finding the equation of the semicircle. Negative 1, 2, 1. How many people have written the equations of circles before? Now here's the thing. Did any of you make an effort to look it up? Just checking. 1? That's better than the other 2 classes. The other 2 classes kind of had cricket eyes. There's 2 places you could find this. 1, your book, which I sent you home with on day 1. Or, what's a great place to find basic information? The interwebs, right? Literally go to any search engine, type in equation of circle Wikipedia, boom, you have great information right there. There's tons of information out there. A circle, radius 1, center at the origin, if you looked it up, it's x squared plus y squared is equal to 1. Is that a function? Is a circle a function?
No.
Why not?
Vertical line.
Fails the, we'll do this like one word at a time. It
fails.
Vertical.
Ooh, I like that. That's a really good one. I'm going to do that again. Such a good teacher. Come on, it's funny. Why don't you guys laugh at me? Come on. Well, okay, that's not a function, so we need to break it up into enough functions that can be put together to make that relationship. It's not written in a form that we usually see. Why? What's different about how this is written? Let's use a hand. Someone raise their hand. What's different about this? Yeah, Solon.
Equal to 1.
It's equal to 1. What form do we usually have these in? Y equals something. So what do we need to do? Solve for y. Isolate y. So if we isolate y, y squared is equal to 1 minus. Y is almost alone. It kind of has a little dual personality right there. We need it singular, so what do we do? Yeah, you take the square root, but what do we have to make sure we also do? Yeah, because we added in the root. We added in the radical, so we have 2 functions. We have y is equal to the square root of 1 minus x squared, and y is equal to the 1 minus x squared. Yeah.
I looked it up in the equation I saw was y equals plus or minus the square root of r squared minus x squared.
That is correct. What's the radius of the circle?
Yeah, no,
What's 1 squared? Yeah, absolutely. Yeah. The general, if you want the general formula of a circle, that's actually a good question. It's this. It's very simple. What's h and k, or what is hk? It's the center of the circle, and r is the radius. So is it pretty easy to write the equation of a circle if you know the radius and center? Yeah, you literally plug the values and you stop. You don't multiply it out, you stop. That is the equation that's the equation of that circle. So we have 2. Are these functions? They are. We'll call this function A and function B. One of them is the top arc and one of them is the bottom arc. Without actually plugging this into your calculator, how could you easily figure out which one's the top and which one's the bottom? Hands, hands. Someone new, hands. How do you figure out which one is which?
Which one is which?
One of these is the top. A is the top or B is the top. How do you figure out which one's the top function? Yeah.
Negative or positive value.
Well, specifically, here's the whole circle, right? How do you figure out which one is the top and which one's the bottom? Pick a value. I mean, you pick a value. What value do you want to plug in? 0. Because at 0, the top arc is at 0, 1. So when you plug in 0 for x, what should you get out? 1. Plug in 0 right there. What do you get? Plug in 0 right here. What do you get? So this is the top, and this is the bottom. Okay, so now we have the functions. This right here, which we should actually do out. If this is 2, 2, and this is negative 1, 0 right here, how do you find the negative 2, 0? Thank you. How do you find? What do you need to find first if you're finding the equation? Ah, bingo. So we have 0 minus 2 over negative 1 minus negative 2. That's negative 2 over what? 1. So the slope is negative 2. So what's the equation? Now here's the thing I need you guys to get into the habit of using. Stop defaulting to slope intercept. Please stop doing that. I want you to default to y minus y1 is equal to times x minus x1. So you end up with y, I gotta get that out of there, sorry. Y minus 2, I'm picking this point to plug in. I could plug in negative 1, 0 instead. I like negative 2, 2. It's totally a value judgment. Does it matter which point I use? No, I should get the same equation. Y minus 2 is equal to negative 2 times x minus negative 2. So what does the equation come out to be? Y minus 2 and negative 2 times what? Yeah, and you can, at this point, what could you write it as? Y minus 2 is equal to negative 2x minus 4. So y is equal to negative 2x minus 2. So we have our two functions, but this is a piecewise function where we're going to be gluing those two together. In addition to those functions, we need to figure out the what for each of those functions, the domain for each. For negative 2x minus 2, what part of the domain does it cover? What's the smaller x value? What's the bigger x value? So the equation we're looking for is f of x equals negative 2x minus 2 when what? Negative 2, yep, less than or equal to. And then it's the square root of 1 minus x squared when what? And less than or equal to. There's one very small problem, very important thing we need to change about that though. Yes? Yeah, you can't have both of them, so you need to pick. Right here, this needs to be, or you switch it with that one.
But if you graph the semicircle function, it doesn't go outside of that domain anyway.
No, you can plug in one. You can plug in one to this. It can be 0. You just can't occupy that same dot twice, or it wouldn't be a...
Yeah, I know, but do you really need to limit that equation?
Yes, you absolutely need to, because if I just gave you... If I wrote this and said graph that and said, is that a function? What's your answer? No. If I said, what is the equation of the function? This. If 2 points overlap, it's not a function.
Yeah, but I'm saying if you graph the square root of negative 1 minus x squared,
Yes.
it doesn't go past that domain anyways. So if you make the first equation
yeah, you could.
non-inclusive,
Yes,
you
could do this and
write
this.
in the domain for the second one.
Yes, you do. Yeah. But you can in one sec now. You can switch those. Yeah, now.
Well, okay, so I misread it, and I took the circle for a quadratic function, so I had a parabola, and I found it for that, and it's actually the same thing as without the square root. So does that mean that we can just find...
Well, hold on. It's not a... The thing is, a parabola, it's going to look similar, but it's not a semicircle.
But it's like it's the same function except...
Without the square root. Yeah, exactly, yeah. It would be the same function. It would be 1 minus x squared. Yeah, it would be. The only difference would be the quadratic would be on the inside, like this. It's a little faster growing than the circle. Okay, yeah, that happens sometimes. We pretty good? Let's pick another one. 6?
Well, I was just like, I wasn't sure, because it was like, instead of a multiplication sign, it was
This? 6? You didn't have a 6.
False.
You mean 5?
The true and false 6.
You only had to do number 4. She wasn't even in class, and she knew
I
that.
thought you just wrote true and false, and then...
True, false, number 4.
Wait, can we talk about...
and then 4...
Yeah, we're going to do 5.
4.
We're going to do 5 instead, okay? Is that good?
Okay.
So when we get to function composition in a couple of weeks, we'll talk about those little open circles.
Okay.
That does not mean multiplication.
Well, I thought you written true and false.
Function
and then
composition.
4.
Okay, kids, welcome back. Hi. So, Andy. Quiet. So we're finding a domain. We know what we're trying to find, right? We didn't do range in the last class. Don't make me do the range on this question, everybody. I keep on skipping out on the fun part.
Don't make you?
Make me do range. I forgot to do it in the last 2 classes when they asked about this question.
Range is just logic.
Yeah, what?
You can do range just by logic.
Yo, you can. Absolutely, but we didn't do it in the last 2 classes. We talked about the domain and then moved on. What is the domain of a function? The domain of a function is... Okay, whoa. The harmony didn't work there. Yeah.
What about word?
All the possible x values. What's the phrase that I like the most? The set of all input values. What's the biggest the domain can be? All real numbers. Yeah, it's kind of a harmony. And then you start taking away what? You take away from the set of all real numbers the numbers that make negative under even roots and dividing by 0. You don't care about dividing by 0. Are there any division? Is there any division here?
No.
What about square rooting?
Yes.
Yeah. So we need to make sure then that 4 minus 3x squared is what?
Greater or equal to 0.
We need it to be greater than or equal to 0. There's no division, so we don't need to worry about that. If we want to know where this is greater than or equal to 0, what do we need to find first? Raise your hand. Someone tell me here. Someone in the back. Let's go to the back row here. Yeah. 3x squared is when it what? Yeah, when it's equal 0. And luckily, it's kind of nice. So what does x equal? Plus or minus square root of 4/3, which is plus or minus 2 root 3. That should be a familiar value. You see that value pretty frequently in what field of math? Trig. Generally, though, do you like radicals in the denominator? Generally, no. Once you take more math, it becomes irrelevant. You don't care. So you rationalize the denominator by multiplying by root 3 over. Yeah, you're actually multiplying by what? 1. It's called the multiplicative identity. So you end up with plus or minus 2 root 3 over. So those are the zeros. We're not really interested in where it's 0. We're interested in where it's not equal to 0. So we have negative 2 root 3 over 3, and we have positive 2 root 3 over 3, and we have the x value, and then 4 minus 3x squared. When you plug those values in, what do you get out? 0 and 0. Are there any other values of x that make that equal to 0? What? No, there are no other ones. That means all of these values have to all be positive or negative. All of these values have to all be positive or negative, and all of these values have to be all positive or negative. How do you figure out which one is positive, which one is negative? It's pretty straightforward. Plug in a value. Plug in a value. So in between these two, what's the one right in the middle? 0. Yeah. When you plug in 0, what do you get out? No, you're plugging it into there. So what do you get out? 4. Now, these values, you don't know exactly. You could plug in a value and get something close. Does it have to be close? No, it just needs to be to the right. So what's an easy value to the right? Well, let's not even logic it out, okay? Let's go even further.
20.
A billion trillion. How about that? Is that okay? Yeah. Do we really care what the value is that it evaluates to? No, we want to know if it evaluates to be positive or negative. So if you can go on for infinity, go for as long. Choose a trillion. What's 4 minus 3 times a trillion squared? It's going to be pretty negative, right? And what happens if you go to the other side? 4 minus 3 times negative a trillion squared. It's going to be the same thing, because when you square a negative, you get a positive, right? So it's going to be negative. So the middle is positive. So one sec, Hannah, we'll get to this. What's the domain then? X has to be less than or equal to 2 root 3 over and greater than or equal to? Can it be equal to those values? It can. Can you take the square root of 0?
Yes.
Yeah. We had to be careful. We had stuff that looked like this. Can x be 0 in that function? No, because if x is 0, you divide by 0. Can you take the square root of 0? Sure. What's your question?
Will you help me with this during conversation?
Sure. Yeah. So what's going on is all of these values have to be positive or negative. All of these have to be positive or negative.
Every time you drop those lines, you lose me. I don't know why.
Okay. Here's the value 2 root 3 over 3. A billion, trillion, gazillion. Do you agree that that's bigger than that?
Yeah.
What's 4 minus 3 times a billion, quadrillion squared?
4. Negative.
No. 4. What's 4 minus a billion? Is it negative or positive? Negative, right? What's 4 minus a billion? Negative. So therefore, everything has to be negative to the right and left of those values. And then in between, when you plug in 0, what's 4 minus 0? So it's positive in between.
Okay.
So therefore, we want it when it's positive, so it's in between. Now, just to give you a preview, there's a better way to write that notation. This right here, you can write it as the absolute value of x is less than or equal to 2 root 3 over 3. Why? Absolute value means distance from 0. If you're sitting here at if you're sitting there at 0, how far to the right can you go? 2 root 3 over 3. How far to the left can you go? 2 root 3 over 3. the distance. If I sit in this and I go any direction, right? If I said the absolute value of x is less than or equal to 2 or 3 over 3, what's the farthest you can go in either direction? So therefore, this is the same as this. Why is the bottom one a little bit nicer to write than the top one? It's not as long. Literally, it's not as long. Mathematicians love to write things in shorthand. For example, no, like, either way is okay. Do you know what that means right there?
Wow.
I'm just giving you an example of where mathematics gets you to. That's a great guess, but it's actually not. It's such a good guess, though. That's a great. There are in the math world, there are terms and whole words that mean several different things. Which, when you think about it, it sounds kind of crazy. But then you think about English. How many words in English mean 7 things, right? Solnit. Oh, you can just quiet. This means, if you want to see this, for all x greater than 0, there exists a unique n such that, and I'll color code it for you. For all, that's that symbol. That right there is there exists. This one right here means unique. And this one right here means such that. The point is, in math, literally, if you can speak 200 common words, you can describe just about every math proof there is. It's a very limited vocabulary. So instead of writing out whole words or translating this, like if you wrote this out in Hungarian, for example, each word has a Hungarian word, which is harder to learn. But symbolically, what is the true universal language? Math. Have you ever seen the plates they put on the Voyager probes? Do you know what the Voyager probes are?
They were space things.
They were space things. Yes, they were space things. That's better than. Seriously, do you know what the Voyager 1 probe is?
Isn't it the one that was trying to go out of the solar system?
Yeah, good for you. Voyager 1 is the man-made object that is furthest from Earth. It has exited our solar system, which is very far away, and the Voyager 2 is pretty far behind it. Well, it hasn't been sending any data back for a long time, but the point is, on each of these long-distance satellites that are just traveling out, there are plates on them that are specifically designed with the best guess as to something that would be able to be communicated to another intelligence if it was found. It's an interesting field. How do you do it? You can look up these plates to see what they look like. It's phenomenal. So Voyager 1 has Voyager 1 has a gold plate on it. It's like this big, and there's different. You can read about what's on it, but then the Voyager 2 has a gold record on it, and it's embedded with like data in, I don't know what it's in, like either in bind or something. But the point is, guessing what civilizations will be able to do with it is very hard to do.
Isn't gold sort of a dumb idea? Because it's so heavy.
I think weight has nothing to do with it. I think how long it can last in terms of degenerating. Also, it's the vacuum of space, so it more has to do with if it could sit in space for eternity. If it gets hit by an asteroid, it's going to get destroyed anyway. The point is, it's whatever it doesn't degrade, and gold is, I don't know. I don't know if it's all gold. It might be some alloy. But you can look that up. And did anybody read about what Stephen Hawking said recently about, actually said about last year, about what his thoughts were on contact with alien life? Does anybody know? It was kind of mischaracterized, but he said something really interesting. No? And I'm going to pause just for a minute because this really doesn't need to get into the notes. Separate your questions and answers. You can think about, well, you have to do at least 2 questions. There are 5 topics. I listed them I'll put them at the bottom. The 5 topics, they're in the syllabus. You can find them. They've been listed out. So that piecewise functions, domain range. Try to make them creative and interesting. Someone else in this class is going to be working on them. So if they're pretty boring, it's going to be boring for them, and they'll tell you. It could be something like 1 easy one and 1 hard one for each topic. Don't make it too easy, or it's not something that's going to be too helpful. And don't make it too hard, and the same thing is true. Make the questions have questions. That means that you can't just put f of x is something. You can't just go f of x is blah and expect them to know what you want them to do with it. So say graph this or factor this, something. You have to put questions in there. It's amazing how sometimes it gets these statements, like pony, and you're like, okay. Try to be as specific as you can with the questions. Multiple parts is fine. Be neat so the other person can read it. aimed for the questions to be fair. Don't make them too killer hard. Make sure you write the answers. You have to solve all of them. You can use books, notes, the net, anything for inspiration. You can use the question directly if you think it's really good. The point is it needs to be clean, neat, thoughtful, and about the length of what you think the test should be.
So 5 questions.
No, 2 for each of the topics, so at least 10.
Oh, 10?
Yes.
How is that?
There's 5 topics, 2 of each, 10. So at least. So the topics are, I'll paste it in, reasonable, so don't make them too hard.
No, you're just like something topic.
Something topics.
Make sure the questions. Make sure the question is blank.
Make sure the questions have questions. That word right there? Sorry. Okay, kids, we're not done yet. So here are the topics. You can start working on coming up with your questions right now.